Chapter number 6, alternating current. Now there are two types of the signal. The one type of the signal is the DC signal, and the other type of the signal is a AC signal. This is a diagram of the DC signal, this one, and this is the diagram of the AC signal, and this is a symbol, the symbol of the DC, and this is the symbol of the AC signal. Now, okay, so in the DC signal, if okay, so this is for the current. Okay, for example, it might be current, it might be voltage. So if it is plus, so all the time it is only plus. If it is negative, so all the time it is negative. Okay, for example, if this current is plus 10 ampere, okay, in the circuit, so all the time it is plus 10 ampere. And if it is say minus 10 ampere, so all the time it is minus. Okay, it will not go to the plus. Now this is a right hand side, this is the AC signal, and this is in this picture. Okay, on the y-axis this is the EMF voltage, and here the voltage is going to the positive, and this side the voltage is going to negative. So at the same time the voltage is positive and negative, both are possible in the AC signal, both are possible. Now, so the different forms of the AC signal. So this is a form number 1, and in this form on the y-axis there is a current. Okay, so the meaning is this is a current signal, and on the x-axis the time is there. Okay, so this is a AC current signal, and here the number 2, this one, here on the y-axis the voltage is taken, so it means this is the voltage signal, and on the x-axis the time is taken. Okay, so this is the AC voltage signal. But sometimes if I need to compare sometimes, so at the same time I can take the voltage and the current on the y-axis, and on the x-axis I can take the time. Okay, so I have to take the two signal. Okay, something like this, the one signal is for the voltage and the other signal is for the current. So at the same time this current and this voltage I can take on the same axis. Okay, sometimes if we have to compare. Now, this is the AC voltage signal function of time. So on the y-axis, the voltage is taken, and on the x-axis this time is taken. But here, particularly in this diagram, the time is given in millisecond. Okay, so if you are calculating something, so you have to change this data to second, and here the voltage is given in millivolt. Like so, this millivolt you cannot take, you have to change millivolt to volt, like that. Okay, so here this way sometimes we can use, and this side, this signal, okay, this is telling the angle of the signal. Okay, so the signal shown here, this is only one signal from here to here. So if I start from here and this point, okay, for example, if I say this is the A point of the signal and this is the B point of the signal, so the A point to the B point, it is the signal is moving from a 0 degree to 360 degree, like this. Okay, so and this is for the full wave. Okay, this is for the one wave angle, the angle of the one wave. Okay, so you can see here, okay, this is the half wave, and this is a half wave positive, and this is half wave negative, so it is making the full one wave. And the signal starting from the A point, so where the signal touching this line, this is an angle now, not a time here. So this on the x-axis I am taking the angle. Okay, so this is the angle of the wave, and where the signal starting from this point, okay, from this point, so this is a 0 degree, and this point, okay, this point is the maximum of the wave. Okay, positive maximum of the wave. So if I go on the angle line, okay, here, so this is a 90 degree or pi by 2, same meaning in the radian. Okay, in the radian pi by 2, and in degrees it is 90 degree. Okay, now the signal, okay, so if I am coming here, okay, so this point is touching, this is zero, this is zero line. Okay, so it is touching the zero here, like that, zero line. So okay, so and up to this point, it is completed the half signal from here to here. From here to here, this is the half cycle, or this is a half wave. Okay, so the angle of the half wave is pi. Okay, the pi means it is 180 degree. After that, okay, the signal is half signal is going down in the negative side, and this is the maximum. Okay, now this is the maximum of the wave, but this maximum is going in the negative side. Okay, so this is equal to 270 degree, or in the radian this is 3 pi by 2. So this is this, this is always, okay, it will come here. So this is 270 degree. Okay, now again, okay, so again the signal is coming to touching to this line. Okay, this line, and this the angle of the wave at this point. Okay, so up to this point half cycle completed, and this half cycle completed. So from up to this point, okay, up to this point, how many wave completed? One full wave completed. Okay, so the value of the angle here, this is 2 pi. Okay, or this is 360 degree. Now this is another few, okay, few information or few, okay, terms are there. Okay, for example, this is a signal, and okay, from here to here, okay, from here to here, this is positive half cycle, or half signal. Okay, half cycle. And from here to here, okay, this is a negative half cycle. Okay, now this one. Okay, so on the y-axis, okay, as I told you, sometimes we can take the voltage, sometimes we can take the current. Okay, sometimes both. Okay, so this point, okay, so this is a maximum point. Okay, this is a maximum point in the positive side, and this is also the maximum point. Okay, the maximum position in the negative side. Okay, like that. So for example, if I take the voltage, okay, so this might be current also. So voltage, okay, if I say here, the number is 10. Okay, so this is coming, okay, this is coming 10. So okay, so I can say the maximum voltage is here, this is 10 volt. Okay, also there is a one more name, that is a peak. Okay, so the maximum, okay, if I say the maximum, or if I say the peak, okay, it has the same meaning. So if I say, okay, if I say this is a peak of the signal, okay, or if I say that is a maximum point of the signal, it has a same meaning. Okay, so if I say, okay, if I instead of this, okay, if I write like this, so this is same meaning, peak. Okay, and sometimes we write in the short form, okay, the voltage, and this is the maximum voltage as a m, and here this is a peak voltage, so it has the same meaning. Now, okay, from this positive maximum to the negative maximum, this is known as peak to peak. Okay, this is known as peak to peak. So this is known as peak, this is known as peak to peak. Okay, from this point, okay, if I say this is the maximum, okay, the positive side, and this is the maximum and negative side. So from this maximum positive to the maximum negative, so from here to here, okay, from here to here, this is known as peak to peak. Peak to peak. Okay, if for example, if I, okay, if I write some value here, if I write this is 20, okay, 20 volts, and this is minus, this is plus 20 volt, and here it is coming minus 20 volt. Okay, so what is the value of the peak to peak voltage? Okay, peak to peak voltage we write like this. Okay, peak to peak voltage is the voltage from here, the voltage from here to here. So the voltage, okay, here we have to ignore this sign. Okay, we have to ignore the sign. and the voltage from here to here, okay, 20 volt, and the voltage from here to here, that is again 20 volt, irrespective of the sign, okay, plus or minus, okay, anyone. So what we have to do, we have to make the total of this. So this is 20 volt and this is again coming 20 volt, so the peak to peak voltage is coming 40 volt, like that. So sometimes, okay, this is another word, okay, sometimes we use, and basically this is the maxima of the wave, and from the maxima of this line, okay, and this we are saying, sometimes we are saying this is the amplitude of the wave, okay, amplitude of the wave is nothing, this is equal to the v maximum, okay, if it is a voltage signal from here to here, this is the amplitude of the wave, okay, how it is shown here, like this is the amplitude from the maximum point to the zero line, like this is the timeline, zero line coming here, this is the amplitude. And from this maxima, okay, from this maxima to this maxima, this is known as peak to peak voltage. Okay, now here again, this is one another diagram, okay, so this diagram is have some scaling, okay, scaling is also given. Now if I say what is the value of the peak voltage, so the value of the peak voltage is, okay, first you check how much it is coming, okay, so this is in the voltage, and so the peak voltage is 4.5 volt, and peak to peak, okay, the peak to peak is the double of this, okay, the double of this. So peak to peak means the voltage from here to here, like this voltage, okay, so it is coming how much, okay, it is coming how much, it is coming, okay, so this is coming how much, this is coming 4.5 volt, and from this is not zero here, okay, this is not zero here, in this case it is not zero, so from here to here, okay, so this is how much it is, okay, so the value of, okay, so the value at this point, okay, this maxima, so in this okay, in this diagram, this is not zero, okay, so most of the time this line is zero, but here it is not zero, so this is a maxima, okay, positive maxima, and this is the max, this is again maxima, but this is a negative maxima, okay, so the voltage, okay, the voltage between this, okay, so here how much coming, this is coming 4.5, okay, where minus maxima is coming, it is coming to 0.5 voltage, okay, so the voltage is running between 4.5 volt to 0.5 volt, okay, so we have to take the difference of this and it will come 4 volt, okay, so what is the value of the peak to peak, the peak to peak is it is 4 volt, like that. Now I will tell you, okay, now I will tell you the time period and the frequency, okay, how to find from the signal. Okay, so the time period, okay, so how to find the time period from the wave, the time period is the time, okay, this is the time of the, this is the time of the one wave, the time of, this is the one wave, like this is the one wave, so this is the time of the one wave, okay, so if I, there are many ways to identify the one wave, okay, so for example it is a time here, okay, it is a timeline, and if I am starting from here, okay, so this wave is going up, this is half, okay, positive wave, and it is going down, okay, so this is a one wave, okay, from this point to this point. Now the time, okay, the time of the one wave is known as the time period, okay, so I have to, okay, so this is the time of the one wave, so it is starting from where, it is starting from, okay, it is starting from, okay, this is the timeline, okay, it, this is the timeline, this is a 0 second, and it is starting from 0 second, and it is going to where, it is going to somewhere after 15, okay, so after 15 I can take this 15 is here, okay, so this is 15, so the time of the one wave is 15 second, okay, so what is the value of the time period, the value of the time period is 15 second like this. Okay, but there are another ways, okay, to find the time period. I can, the time period is also, okay, this is time period. And also sometimes, okay, this is this is the first maxima, okay, one maxima. And this is the other, okay, this is the other consecutive maxima, other next maxima. So the time between the two maxima, so okay, from here to here, this is also the time period. Okay, so if I take this value is how much, it is not coming exactly on the scale. Okay, but if I take here, like this is coming to, this is coming to the 5 second. And if this is coming to how much, it is coming to, this is 20. Actually it is this, and it is this, and it is this, and okay. So this is coming, this coming, this coming, this coming, so this coming 20. Okay, so this coming 20. Okay, this coming 20. Okay, so at this line, at this line it is coming 20 second. Okay, the position of this maxima, okay, on the timeline is 20 second. And the position of this is coming 5 second. Okay, so the difference between the 5 second and the 20 second, okay, so it is like 20 second. And then it is, okay, then it is 5 seconds, so this is 15 second time. Okay, so this is another way. Now, okay, so another formula is the formula for the frequency. And the formula for the frequency is, this is 1 over t. And 1 over t, okay, for example, if I take this 15 second, so this is 1 over, it is 15. Okay, so how much answer will come? That is the frequency of the signal, and it will come in the unit of hertz. Okay, so now I told you, okay, how to find the time period, and then how to find the frequency from the signal.